Okay, listen, this is simply mind-blowing. Forget for a second all the bureaucracy and hype. Let's break it down from first principles. A space telescope, an absolutely phenomenal machine, by the way, pointed its sensors at a planet 120 light-years away, K218b, and it detected dimethyl sulfide DMS in its atmosphere. So what, you ask? Here's what. On Earth, this molecule is produced exclusively by life, phytoplankton, microscopic organisms in the ocean. There is no known geological process, no weird abiotic chemistry that just casually pumps out DMs in detectable amounts. It's a bona fide biosignature, and now we're seeing it there on a planet in another star system. This changes everything.
When the same analysis later found traces of dimethyl disulfide, DMDS, another strictly biogenic compound, the silence from space agencies turned into something more unsettling than a simple press release, a conspicuous lack of denial. The researchers kept repeating that the data had been confirmed, and moreover, they were obtained in an atmosphere made of water vapor, methane, and carbon dioxide, the key triad for organic life as we know it. Yet, even with such compelling evidence, nobody dared to utter the forbidden word, life, acknowledging it would shatter the spell of the paradigm that had been comfortably sustained for decades by convenient skepticism. We are alone. The problem is that now the universe seems to have started answering back. K2-18b is not a second Earth. It's a transitional world, larger and denser, 8.6 times Earth's mass, 2.6 times the radius. It belongs to the Hycean class, a new theoretical category describing ocean worlds with hydrogen-rich atmospheres. Its star is a cool red dwarf that bathes it in dim light. But the planet sits right in the habitable zone, that narrow band where water can remain liquid. Imagine a global, deep ocean covered by a thick protective atmosphere where complex chemical reactions are possible, the same kind that billions of years ago sparked life on Earth. This isn't just speculation. It's a reconstruction based on cutting-edge spectroscopy from the James Webb Space Telescope. The data were so clear that they demanded a new interpretation. Science found itself facing an unbearable dilemma. Either there is life there, or our understanding of planetary atmosphere formation is profoundly incomplete. Neither option allows us to keep the old, comfortable certainty that life is an isolated, ultra-rare phenomenon. How do you come to terms with the fact that a planet so different and so far away is producing the exact same compounds without the exact same reason? In every leading university and lab from Cambridge to Caltech, the same question echoed. Are we witnessing a new kind of planetary chemistry, or the first confirmed alien biosphere? The answers converged on one point. Nothing in the known geochemical catalog can explain such abundance of these molecules. And then the paradigm began to crack. The real breakthrough wasn't scientific. It was symbolic. For the first time, possible confirmation of extraterrestrial life didn't trigger panic or mass denial. Instead, a reverent, tense, almost religious silence fell. Why do we pour billions into space if, deep down, we aren't longing for an answer? And what do we do if that answer has already arrived? Micro-conflicts started popping up everywhere. Scientists split into camps of caution and enthusiasm. Philosophers argued about the meaning. Religious groups responded with a whole spectrum, from confirmation of divine creation to a threat to spiritual order. And society, for the first time, faced a question it could no longer ignore. The most disturbing thing isn't the existence of life elsewhere. It's what it reflects back at us. If life exists somewhere else and shares the same molecules with us, then it's not a rare accident. It's a natural consequence of the way the cosmos is built. The universe stops being an indifferent stage and turns into a fertile, pulsing, perhaps even conscious organism. And here comes the question that starts tearing the fabric of modern beliefs. Are we ready to accept that we are not the center of universal biology? And more importantly, maybe we're just one chapter in a much longer book written by molecules, oceans, and atmospheres. K2-18b is inviting us to make contact. It's not blinking lights or sending radio waves. It simply exists. And its very existence challenges us, because if what we're seeing is real, the universe was inhabited long before us. When the news was confirmed, it spread across the world through phone screens, forums, and podcasts. The abbreviation K2-18b trended for a week. This distant planet managed to do what no global event ever could. For a moment, it made the whole world fall silent and look in the same direction. The eternal question, are we alone, was replaced by a far more uncomfortable one. What changes when we stop being alone? Behind the scenes, astrobiologists were facing the real probability that life might be commonplace. That idea hits human pride harder than any alien invasion ever could. Pride that for centuries rested on the belief in our uniqueness, but now the simple appearance of a biogenic molecule where it shouldn't be is shattering that certainty. This isn't just a scientific shift, it's a civilizational one. The reaction was global. Buddhist monks in Kyoto held a ceremony of cosmic contemplation, celebrating not aliens, but the confirmation of a living cosmos. The Vatican stated that extraterrestrial life does not contradict Christian principles and is part of divine creation. In Europe, curricula began to be revised to include applied exobiology. In France, philosophers and climatologists discussed how the discovery of distant biospheres should affect our ecological behavior here. The reasoning was simple. If life exists elsewhere, the value of life here skyrockets. The most unpredictable effects happened in private lives. Teachers started lessons with images of K2-18b, and students began asking deeper questions about their place in the universe. Artists created installations conveying the feeling of being watched by something faceless yet conscious. Searches for extraterrestrial life surged 640%. Culture began adapting to a new reality where contact is no longer fiction, but probability. And yet, amid all this, a quiet longing grew. If life is out there, why is the universe silent? The Fermi paradox took on a darker shade. Perhaps the answer is that life exists, but it's microscopic. It doesn't build ships or send signals. It just breathes, absorbs light, produces molecules, and maybe evolves. The idea of loneliness has always been our armor, our cosmic alibi that justified arrogance and the destruction of our own planet. But with the shadow of another ecosystem comes cosmic responsibility. This silent world shows us what we stand to lose, that if life 120 light years away can't send a message, then we remain the only ones who can speak on its behalf, protect its story, and preserve the fragile thread that connects carbon, time, and consciousness. And that changes everything. If this text resonated with you, share it with someone who still believes the universe is indifferent. Every great shift begins exactly like this, with a world that demands to breathe and with eyes ready to notice.